All right, so welcome back. Factoring difference of squares. This is still a topic with regards to primarily quadratics in grade 10. And before you tackle difference of squares, you should know what perfect squares are. Now, perfect squares, I'm going to put up a link up above. If you haven't watched that video, please do so. Now, if you recall from perfect squares, what happens is that you can take your factors. So let's say, imagine that we had this, x plus 2 and x plus 2. So this makes it a perfect square because it has both, or all the sides are identical. In this case, they're all x plus 2. And if you take the area, so if you multiply the two sides, you're basically going to get this. And what happens is that if you expand this, you're going to get x squared plus 4x plus 4, and that is the result. So this would have been the area that you would have had. Now, what makes this a perfect square is that both of the factors are actually identical. So it's x plus 2 multiplied by x plus 2. That's what makes this a perfect square, because they're identical. Now, the key difference is that in difference of squares, so what happens here is you do not change the actual, so this case, the actual factors, so there's still x, okay, this is going to be x plus 2, and then the second factor, what happens, and this is where the difference comes, is that it's still an x, and this is still a 2. But the sign is now going to change, and that is the difference, and that's why we call it a difference of squares, because one is positive and then the other one is negative, which means it's no longer a perfect square. It's not necessarily a perfect square that you have. Now we call this a difference of squares. And what happens with these difference of squares? This is probably the easiest ones that most people will try to remember when they're factoring out. At least that was the case for me. Because something very nice happens here to the middle term, which you would always have in these quadratics. So if I expand this, if we're going to take this thing and we're going to expand it out. So I'm going to have still, so you notice that this is still going to be x squared. All right, now x times the negative 2, so this is going to be negative 2x. Then I'm going to take the 2, I'm going to multiply this, I'm going to get the 2x in here, and then finally I'm going to get minus 4. And your middle term right here, whenever you have a difference of squares, so this term, notice, because it's negative 2x plus 2x, disappears, so it will vanish. And therefore, so what this becomes is that your quadratic, okay, this is no longer a trinomial, it's actually a binomial because there's just two terms. And now this right here looks pretty nice. And if you have these difference of squares, and if you're going to notice that if you take the first term, so this term right here, and you take the square root of it, notice that this is going to be your x. And then if you take the square root of your 4, which is going to be your 2, that's what you have there. Now, because there is no middle term, then as long as you have this sign, so this sign in the middle is a negative. If you notice that's a negative, and both of these can be taken the square root of, then you have a difference of squares, which means that this is going to be, one of them is going to be plus, and then the other one is going to be minus. And again, that's going to yield you that back. This is one of the easiest factoring out ones that you have. Now, the only thing is you have to recognize them. So you have to recognize that the first term you can take the square root of, the last term you can take the square root of, and in the middle the sign is always negative. So it cannot be positive, because if it's a positive, then it's not a difference of squares. Let's take a look at a few examples how we can try to see these through. So here are 3 examples, and I'm going to show you that these are difference of squares. So again, so what I do is I'll see if for my first So term, so right here, if I take the square root of that, I'm going to just get x. If I take the square root of my last term, that's going to be 9. And now because I have a negative in here, then I know right away that it's a difference of squares, meaning that that middle term would have been dropping out. So here this is going to be plus, and this is going to be minus. So it is a difference of squares because this times this is squared, gives you x squared right there. 9 times 9 gives you 81 because it's squared. And the difference of squares comes from the fact that the signs are different. And that is the factored form of that first example. In your second example, we can do exactly the same thing. So I can try to see. Okay, so I'll take this, take the square root of that. I'll take this and take the square root of that. And what I'll get is, so in that case, it's going to be 2y. And this is going to be 5. The middle sign, so again, it has to be negative. If that's negative, great. I have a difference of squares. So I'm going to take that. And then 2y minus 5. So your difference is the sign. And then the other two are just squared. And you can test this. So I encourage you to test it, a couple times for yourself so that you see. Meaning expand it out. So if you expand this, you're going to get 4y squared. And on the back, you're going to get 25. And now in the middle, what you have, because you're multiplying this times this, which is going to be minus 10. And this is going to be y. And then you're going to take these two terms, okay? And then multiply them. So this is going to get plus 10y. And notice that indeed this drops out, okay? Minus 10 plus 10 is 0. So you return back to what you started with right here. That is called a difference of squares. Now the last one, so this example, now that you've seen this, you can probably figure it out. So notice, key thing is, it has two terms. Okay, great, this one has a negative. So what I'm going to do is I'm going to take the square root. So that means it's going to be 6z squared. That's going to be 1. And then the other one is going to be 4y. And this one's going to be plus. And this one is going to be minus. Now, which one is, if you put a plus here or a minus here, doesn't matter. You can switch those signs. That's still going to give you the same thing. But the key thing is that those two signs have to be different if you want that middle term to disappear. And that's how you tackle these difference of squares and how you factor them out if you do run into them in school at some point. I hope this was helpful. Bye, everybody.